morning. The last question of part 2 is to write a function polynomial list which accepts a list with numeric entries and returns a polynomial. A polynomial is string type. For example, if I give it a list of numbers 2, 3, 5, -4, it should give me 2 plus 3x plus 5x squared minus 4x cubed. Okay, polynomial of the empty list must give me 0. If I asked to evaluate the polynomial at 2, I must substitute x equals 2 and result should be -4 as it says. What is the derivative? Derivative of constant is 0. 3x should reduce to 3. 5x squared, that 2 should come down. 2 times 5 is 10. Power of x goes down by 1. Likewise, -4x cubed, that 3 should jump down, become a -12, and power should reduce by 1. Okay. Lastly, integrate. If I give you a list, so that 2 should become 2x, 3 should be 3x squared over 2, 5x cubed over 3, minus 4x to the power 4 over 4. So notice the coefficients. All right. So 5x cubed over 3, that is 5 over 3 is this quantity. Here 4x to the 4 over 4. So 4 over 4 gives me a 1 there. Negative is a negative. All right. So this is what we wish to do. So I have written a code for this, and that is polynomial.py. Okay. So open it with idle. Okay. So remember, all your codes must have proper documentation. Tell me your name, the file name. You are defining the polynomial function using a list L. You are starting with an accessor. So begin with the string of L0. So begin with the constant term, correct? And then as you go over the length of L, right, starting from 1, anytime you have 0 coefficient, you pass, you don't do anything. But the moment you have a coefficient, suppose the coefficient is 1, then all you are going to do is x to the power that position. You understand? Now, anytime your coefficient is a negative, I'm going to place it within parentheses. All right. So, and x to the power I. Otherwise, that is, if it is coefficient is not 1, not 0, and not negative, then you are simply going to convert the coefficient to a string, concatenate it with x to the power of that power. All right. Now, you are going to join all this with a plus, and that's all. Evaluating at 2, initial value, this is also an accessor. Let me say accessor. And now, not accessor, sorry, accumulator. And now I evaluate it. So instead of x, I have 2. So 2 power I. Whatever that is, multiply by the coefficient and increment your value. Return that value. Derivative. Derivative means, so if you, I hope you understand the meaning of derivative. If you don't, let me explain it. So let me write it here. You will notice. Okay. So derivative. So let me say expression, and I'll write its derivative over there. Derivative. So if the expression is x to the power, if the expression is a constant, its derivative is 0. If the expression is x power n, then its derivative is n x to the power n minus 1. All right, that's what we are doing. So anytime you see that I comes in because of this n, the power comes down. All right, so that's what we are appending. We are creating a derivative list starting from 1, because when the constant term gives you derivative 0, so it's bumped off. So you don't start with 0, you start with 1. Okay, and now whatever list you get, create a polynomial out of it. Now integration. Okay, now suppose integration, if I want to do, so expression is here and its integration is over here. So it is simply the opposite. If you have a constant, any constant, okay, any constant, say then its integration is c times x. Okay, what happens if your constant is 0? Right, now that's an important one. Then its integration is a constant. All right, so here I have to make a note here. It should be non-zero constant. All right, so in general, if you have x to the n here, then its integration is x to the n, the whole thing, oops, x to the n plus 1, sorry, n plus 1, the whole thing over n plus 1. All right. So increase the power of x by 1 and divide by that new power. That is your integration. Okay. So these are the rules we are using in our polynomial. So integrate. So look, we are increasing the, so we are going to divide by I plus 1. This process is telling me to round so that I don't have too many decimals and such things. Okay, I don't want something like this to happen, so I'm rounding it up. If I don't round it up, that's okay, then I'll get something large like that. Okay, so that is the integration. Let's play with it, run it. Okay, so you have found all the, this is your polynomial evaluated at 2, that polynomial's derivative is here, that polynomial's integration is over here. Okay, mind you, no matter what code you write, you need to have module testing done. Okay, so you write this command at the end and all the module testing is done. So if double underscore name double underscore is double equal, so that is a conditional. Okay, main So double underscore string main colon, then print this so that I can see what's happening. All right. So I hope this gives you enough preparation for the midterm. All the best with your studies. If you have any questions, feel free to send me an email. If you have any other, if you want to meet face to face, then let's meet again on Wednesday between 10 and 11 on Blackboard Collaborate. Until then, good luck, stay safe,